Hi, awesome Science 2 kiddos. I'm going to use this video as just a short overview of Hewitt chapter 29.7, which I encourage you to read to complete the quiz on Canvas. It starts off with looking back in time and describing the science of cosmology, which is just the study of the overall structure and evolution of our universe, which is an unimaginably large space. The best tool we have for looking outwards from our planet is telescopes, which are literally just little devices that use lenses to capture and magnify light from distant stars. But it's very limited because while light does move really, really fast, our universe is also extremely large, and therefore it's kind of mind-boggling, but the reason we're looking back in time is because when we look at a star, we're not seeing that star as it currently exists, we're seeing it as it possibly existed up to a couple million years ago, because sometimes it takes up to 1,000,000 light years for that light to reach our planet. And so if there are intelligent forms of life out there that might be looking towards our solar system and possibly looking at our planet, they might be looking at the dinosaurs or something, maybe even a lifeless planet, because the light emitted from Earth that's reaching them is extremely old. Because again, even though light moves so fast, everything is so far away in our universe. So the general rule and the key takeaway from this is that the farther away an object is, the older it is. And this is what led to some breakthroughs in cosmology. Edwin Hubble was working in the 1920s. He was using a large telescope to look outwards, and he made some interesting observations. First, that there were other galaxies that existed, right? So the one we're in was not the only one, and that they seem to be spreading out from each other. They're moving. And so this has two big implications that you need to take away from it, right? The first is that since everything's moving outwards, there must have been a starting point, right? And it's this idea that the universe arose from an explosion, right? A big bang. That it started from this singularity and is now moving outwards. And it is still expanding and creating space as it goes. Which I know is a little weird to think, but there's more universe being made. Your book uses this analogy of a balloon that is covered in ants. Think of those ants as galaxies. And so as the balloon expands, those ants are all moving farther and farther away from each other. But from the ants' perspective, no matter which point you choose, everything seems to be moving away from them in that point. So if you have that question, like, well, okay, where did the Big Bang occur then? What is the original center point? You really can't identify that. Anything could be the center point because, again, think of it like the elastic in a balloon. No matter what point you look at, everything is expanding out from that point. Everything is just moving outwards. Kind of an interesting way to think about it. But that is the origin of what was called the Big Bang Theory. Hubble also came up with a relationship we call it Hubble's law, but it's a proportional relationship between the distance of an object and from Earth and the velocity at which it is moving. And as you can probably predict, if everything's moving away, the farther away an object is, the faster that object is moving. Or think about it as objects farther away are moving faster than objects that are closer. And you can see that in this equation right here, v equals h times d. V was the velocity of the galaxy. It's usually measured in kilometers per second. H is Hubble's constant, which the current value is 73.8 kilometers per second per megaparsec. This number is actually still kind of in debate because there's a lot more research and calculations being done. Hubble originally proposed 500 kilometers per second per megaparsec, so you can see that's changed a lot. And distance, d, is measured in megaparsecs, which is 3.26 million light years, which is a distance that I can't even wrap my mind around. It's extremely, extremely far and really shows you how vast our universe is. They did a lot of complicated math and calculations and observations, but it is widely agreed upon now that the age of our universe is about 13.7 billion years. That's Earth years. So again, it's an unimaginable amount of time and shows that the Big Bang occurred a very, very long time ago. Now, just to do a little algebra, hopefully you are familiar with a little bit of math, but if we take Hubble's equation, v equals Hubble's constant times distance, remember that velocity, v, is actually just distance over time in this equation. So what if we swapped that in? What if we took this value of v here, the h times d, and plug that in for this velocity value, right? So let's replace velocity with Hubble's law. So there you have it. So now instead of v equals d over t, we've got h times d equals d over t. And I'm hoping you notice that we've got distance twice now. which means that we can divide both sides by distance, right? I'll divide this by distance and divide that by distance. And I'm hoping you're familiar with the fact that then if you have got two like variables, they're all going to cancel out. So there's no more distance variable. And we're left with Hubble's constant just being the inverse of time, which again, I'm not entirely sure the mathematical complications or consequences of that, but I think things get a little more complicated when you actually start doing math with Hubble's constant. But that's just some fun little algebra to do. It might help you on that reading quiz. More evidence of the Big Bang is cosmic background radiation. Penzias and Wilson were working in the 1960s. They're pictured here. They built this huge radio receiver, and they were just trying to listen to radio waves in the heavens. Bryson discusses them as having to clean all the bird poop that no doubt got into this large structure that's behind them. But they didn't make much progress because they kept detecting microwaves. No matter which way they pointed their large device, they kept getting these same microwaves. They had a certain wavelength. And at the time, there was other research going on, but they eventually figured out that what they were receiving, these microwaves that they're detecting everywhere, is actually the afterglow of that explosion of the Big Bang, right? The Big Bang generated extremely high temperatures, and the universe is cooling down now, probably down to something of an average of about 3 Kelvin. And the radiation that is emitted by objects that are around 3 Kelvin tends to be within that microwave region. And so again, this is just further evidence of the Big Bang, that there was some kind of large explosion that generated huge temperatures, and things are now cooling down, and they were detecting the consequences of that. Another piece of evidence for the Big Bang Theory is the abundance of hydrogen and helium. Hydrogen, you can see here, it is the simplest element. It is literally just one proton with an electron circling around it. It is the most abundant element because it is simple. The next element on the periodic table is helium, which is a little more complex. It's got 2 protons and 2 neutrons and 2 electrons that are spinning around the nucleus. Helium is actually formed by stars. This is what powers our star, is the fusion reaction of hydrogen turning into helium, basically. Don't ask me exactly how they figured this out or calculated it, but we have a good idea that of all the matter in the universe, about 75% of all matter is hydrogen and 25% is helium. Now, I'm sure it's not quite that clean, but it's basically 3/4 and 1/4. Now, this, though, can't be explained by the activity of stars, right? Stars could maybe account for 10% of the existing helium. That's all the stars in the universe. So the question is, what about the rest? And the prevailing theory is that it was the extreme temperatures of the Big Bang that helped form the remaining helium, as well as most of the other heavy elements that are in existence, though they're in such small amounts that we don't even count them on this scale. So the key takeaway from chapter 29.7 in Hewitt is that there are 3 pieces of evidence supporting the Big Bang Theory, right? That the universe started from this singularity, is expanding outwards. The first piece of evidence is Hubble's observations that the universe is continuing to expand and galaxies are moving away from each other and increasing in speed as they do so. Cosmic background radiation, again, is sort of evidence of an afterglow of a very large explosion, right? High temperatures, and we're now cooling down. And those high, hot temperatures when the explosion first began explain the proportions of hydrogen and helium that we see in the universe today. So those are the key takeaways from that chapter. Thank you very much.